Okay, so if you look over here, okay, they say that the diagram shows the results of electrophoresis, okay, using the amino acid glycine, lysine, glutamic acid. Yeah, so all of them at pH 7. So the buffer solution is at pH 7. So whatever, okay, that you have over there, okay, the charge, if you can identify the charge, you know where they are going to move, left or right. Yeah, so the structure of amino acid at pH 7 are shown. Yeah, so you just check over here. Okay, this one, okay, you see that the moment you see like this, okay, this is your zwitter ion. Okay, so left is COOH and then right is NH2. The H plus from the COOH goes to NH2. Then you have the normal, and then the R group is H, which is going to be a neutral. Yeah, so this is going to be neutral, and pH 7 is going to be neutral, so neutral. And if you look over here, okay, this side and this side is similar, zwitter ion, okay, but the R group contains NH2. Okay, the R group contains NH2. Okay, from where? Okay, there is H plus there. Okay, from where it came? Okay, do remember pH 7, it contains water. Okay, water can give you H plus and OH minus. Okay, so they also get the H plus from that. So they are going to be the moment. Okay, if you don't think about that, also it's okay. The moment you see NH2, okay, the moment you see NH2 over there, okay, they are going to behave as a base. Okay, they are going to behave as a base. So if this amino acid is a base, okay, so you know that, okay, you require, okay, either the buffer solution must be either acid or pH 7. This is going to be come back to question number 1. Remember, I told you I prefer you to write the answer as acid buffer. Okay, but if you use normal water, which is going to be pH 7, okay, it is still going to have H plus from there. That will be given, okay, the proton will go to the NH2 to give you the NH3 plus. So they still work. Okay, that is going to explain about the marking key in question number 1, the first question itself. Yeah, so this one is going to be base. Do remember, the moment the H plus comes over here, the zwitter ion now is going to change into a positive charge. Why? Because of this. Okay, so this is going to be positive charge. Okay, it's a base and it's going to be positively charged. And then if you look over here, this one contains COOH. Okay, zwitter ion. The R group contains COOH. So this is going to behave as an acid. Okay, so it's either you use the base buffer or you can use pH 7. Okay, still the same, because water will give you OH also. So they can actually, the water can receive the OH plus, minus, okay, can react with the H plus from here, okay, to give you water. Okay, so it means still this thing is going to be formed. Okay, but what is the, sorry, not this one, yeah, this one, okay, this one. Okay, so still, okay, a negative ion is being formed. So I'll just put negative ion is still formed. Okay, whether it is base, buffer, or pH 7. Yeah, so please remember this. Okay, so now, okay, if I look at the charges alone, okay, if I put the spot of the mixture over here, this is the positive terminal and this is negative terminal. Okay, and I see RST. Okay, so if you look at R, okay, R is going to be attracted to positive terminal. Okay, if it is attracted to positive terminal, R must be a negative charge amino acid. Okay, so which is glutamic acid. Okay, glutamic acid. Okay, don't actually think about acid. Yeah, no, don't follow that. Yeah, that's just the name. Yeah, so you just have to check. Okay, the structure. This is glutamic acid, and S is going to be neutral. Okay, that is going to be your glycine. Okay, glycine is neutral. Okay, T is going to be a positive charge, which is going to be lysine. Okay, so they are going to go to the negative electrode. So if you put over there, okay, just write down glutamic acid. Okay, and then you just need to write S is going to be glycine. and this is lysine. Okay, so this is going to be you identify. Okay, this is going to be something similar to this question, but I think the previous question is going to be more in detail. Yeah, if you can remember this question. Okay, and I only gave you the answer like whether they are acid, then you react what kind with buffer and so on. But if you go and look at the marking key, okay, they also mentioned that you can actually use the pH 7, yeah, for this as well. So just go and check. Okay, now it will make sense now. Okay, but that one, if you still not sure, you can check over there. Okay, but this one is going to be an easier version of that question. Yeah. Now, so the next question, okay, this one, okay, remember I taught you about two-way paper chromatography, yeah, and I mentioned that not so important, but they did ask over here, okay, under paper chromatography. They didn't specify in your syllabus that they want two-way chromatography, but you can see, yeah, they asked before, okay, and then whatever that is not there, okay, of course they will give you small amount of marks. Okay, I don't want you to focus too much on this, okay, but okay, if you look at this, okay, we try to solve, yeah, so it's going to be they say that this is a two-way chromatography. So you see solvent 1 is supposed to go up, and then solvent 2 is supposed to go up this way, yeah, so the mixture is being applied over here, yeah, so it goes left and right. Okay, so based on, okay, first, okay, depends on what solvent. So maybe the separation from here, it went up, okay, went up, okay, went up, okay, went up, didn't like something stay there, yeah. So, okay, this one stay as it is, okay, didn't get separated. Okay, so when you put at solvent 2, it means they rotate the paper, okay, they rotate the paper. Okay, when they rotate the paper, if you cannot visualize, so I'll just take this one, copy, paste over here. So what they did, okay, they just rotate. So when they rotate, what happened, okay, the separation now is going to go from here, okay, to here and so on. So some sort of that kind of separation, yeah. So if you look over here, okay, just to avoid confusion, I delete this first, okay. Now, if you look over here, okay, they say put U next to the amino acid that travels furthest in solvent 2, yeah. Solvent 2 means they must actually go this way, okay, they must go this way. So you see the one that travels furthest, okay, if you just look at the movement to the right, okay, so the one that travels furthest is going to be this one. This is you. Okay, that is you. Then put a ring around 2 amino acids that were not separated in solvent 1. Okay, so when in solvent 1, you can see there are 2 amino acids that is not separated. Okay, so which is going to be, I'll just put the ring over here, not separated, not separated. Okay, I know it's going to be a little bit tough to see, yeah, but that is it. Yeah, so I don't want to discuss further also, yeah. So they remain at the same RF value, yeah. So put a W next to amino acid that is very soluble in both solvents. It means very soluble in solvent 2, maybe U, yeah. Very soluble in solvent X, solvent 1, maybe this one, okay. But there is something that is soluble in both solvent 2 and solvent 1, which is this one. Okay, which is this one, which is going to be W. Okay, they are soluble and went up from the to the right over here like this, and they are soluble and went all the way to here also. Okay, so they are really soluble in both of the solvent. Yeah, why not? The answer is going to be this one. Okay, this part. This is going to just say that they are soluble in solvent 1, but they are not very soluble in solvent 2. They are still here. U is better soluble, and this one, the one that's circled over here, is a bit is more soluble. Yeah. So another maybe question the student will ask: why not U? U is soluble in solvent 2, but not so soluble in solvent 1. Solvent 1, they just stay there. Okay, so that is going to be the answer for this. Okay, but I don't want to spend a lot of time over here. Okay, not in your syllabus anymore. Paper chromatography is moved. Okay, to it's not moved. I think all the while it is been in the AS syllabus. Yeah, but since they even asked in paper 4, okay, last time, okay, there is no doubt, okay, that they can ask anything, yeah, in paper 4. Okay, so don't be overconfident. Yeah, this one not in syllabus, they will not ask. They will ask. Yeah, so we just need to be prepared. Okay, just need to be prepared in case they ask. Yeah, so that's why those things that I feel that they will ask, yeah, I still teach you. Yeah, so that is done. Okay, so okay, you can check the marking key. Okay, that is done. So the next question, okay, do remember last time, okay, very popular, yeah, X-ray crystallography, yeah. But, okay, I told you X-ray crystallography is no longer in your syllabus, okay. So I erase this part, okay, NMR, okay, let's focus on NMR. So NMR, okay, is going to be an important analytical technique, yeah, which can be used to study the structure and function of molecules. NMR arises because protons possess spin that generates small magnetic moment. Now, if you remember, there was one question asking you how NMR works, okay? And the answer for that can be found in this explanation, yeah? So next time when they ask you similar question like that, I think better to use like this, okay? Because proton possess spin that generates a small magnetic moment, okay? So that will be something that you want to remember, yeah? So when an external magnetic field is applied, proton can align and with or against. If they are given a small amount of energy, okay, in the radio wave frequency range, each of them can be promoted so that their magnetic moment opposes the external field. Yeah, you can read. I think it contains a very good information, okay, about NMR. Now, two factors can influence the energy required for this promotion. What are they? If you do not know, I think you know about this. Maybe currently, if you don't know what to answer, yeah, I'll just let you know. Okay, two factors. Okay, one, okay, the energy required for this promotion depends on, okay, the type of environment. Okay, type of environment that you have. Okay, type of environment of either the proton, okay, or the type of environment of the carbon, yeah. So that is going to be the first type of environment of, in this case, they are talking about protons, so type of environment of protons in the sample. So that is going to be one of the factor, okay. Another factor is going to be the strength, okay. Remember, you change the strength of the magnetic field, the external magnetic field, okay, the strength of the external magnetic field, okay, that is going to also affect, okay. These are two main things that I can think of, yeah. So if you look at the marking key, I think they give more, yeah. So they say the nature of the proton, yeah, but in the end, it's still talking about chemical environment of the proton. Yeah, that is what we want. Yeah, I put environment. So now, from now on, let's actually use the term chemical environment. Okay, chemical environment. And then, okay, the number of spin states the adjacent proton attached to the adjacent atom. Okay, they included that. It means the neighboring, okay, the neighboring proton. Okay, the neighboring proton, and then the strength of the applied or the strength of the external magnetic field. Yeah, so I took these two. Okay, so they are another one. Yeah, any two. Yeah, done. Okay, so a compound J, okay, has this formula C4H10O. The NMR spectrum of J is shown. Yeah, so there are two peak. Okay, there are two peak. And then I have this 9. 9 represents 9 proton having that environment. And then there is one proton having this environment only. Yeah. So indicate the groups responsible for each peak and deduce the structure of J. Yeah. So 9, okay, I think you no need to think so much. Okay, the moment you have 9, it must be CH3, CH3, CH3. That is the only one that will give you 9. But if you are not sure, okay, you can always check. Yeah, the peak at 1.26. Okay, you can just go and check 1.26 whether, okay, that is what we are going to look for. Okay, so 1.26. Okay, so you see here it comes within this range, which is CH3. Okay, so that is going to be a confirmation, okay, that we are correct. Yeah, so it's 1.26. Okay, it is going to be CH3 because 9, yeah, 3 CH3s. And then I do see another one, okay, which is going to be I see another one, okay, which is going to be at 2. Okay, 2. So this one, I know this is CH3. And then pick at 2. Okay, there's only 1. So let's look at 2. Okay, I suspect it must be something to do with oxygen because they say just now in the molecular formula it contains oxygen. Okay, so if I have maybe oxygen, maybe here, no, okay, it's 2.2. Yeah. If I have something, another oxygen, maybe here, no, okay, it's different. Okay, then maybe I try alcohol, okay, maybe, okay. And then maybe if I just look at NH and so on, I think no need to look. I think I can actually just say it can be somewhere here. Yeah. So 0.5 to 6. Okay. So that is going to be most likely. Yeah, most likely. Okay, the compound will have that. Okay. So this one is 2.2. Okay. So here.
You have to guess, sir? Like, you have to guess from the table?
This is just part of the information. Okay, because remember it's the range. They will give you the range. Okay, using the information. Okay, using the information. Now, if you look at it, okay, you are looking at maybe it can be this one. Okay, or it can be CH3O. Okay, but I don't think so. It's CH3O. Yeah. But you get the information. This one definitely not 3.2. No. Yeah. This is no. Okay. So roughly, okay, I suspect maybe this one or this one only possible. Yeah. ROH or C double bond O. Okay. So that is going to be the thing that I know. Yeah. But do remember there is only one peak. So we are not guessing anymore, actually. Yeah, there is only one peak over there. So it cannot be CH3 attached to this. It cannot be this. It cannot be this. Okay, so it's only one peak. So the only one that will give you a single peak is going to be alcohol. Okay, that is how you confirm. But it's still okay. They still give you another detail, okay, that you can use to confirm, okay, which is they give you this detail, C4H10O. There is one oxygen. This will actually help us to guess something over here. So here, okay, while I'm doing this, I already know, okay, this one is going to be OH. Okay, this is OH. And I already know that, okay, what is the structure? Even before, while doing this, okay, I already can identify. What is the structure? This is 9, yeah? So it means that carbon contains CH3 here, CH3 here, CH3 here. Remember 4 carbon, I already satisfy the 4 carbon, okay? And I must have oxygen. Now, if I have oxygen, maybe I can think of aldehyde, ketone, okay, something like that. Okay, if I put a double bond, it doesn't make sense. Okay, because each carbon can only form 4 bonds. Okay, so definitely this is going to be, I have to put OH. And I check, okay, 9 plus 1, so 10 hydrogen. So here is 10 hydrogen also. Okay, so I know that this is confirmed, okay, no doubt, okay, no doubt that this is J. Okay, this is how you identify. Okay, yes, in the beginning it looks like guessing, okay, but you need to verify, okay, based on the data. So you will not have, sometimes only you will have the information that they say it can be either OH or NH, but most of the time the answer is solid. It's like there is no other possibility. Yeah, there is no other possibility. That's going to be the only answer. Yeah, something like that. Okay, so this is going to be the structure of J. I will copy this, okay, for the next question over here. Okay, I paste it here. Now, there are 3 other isomers of J. Yeah, there are 3 others. Okay, same functional group as J. Yeah, same functional group as J. Okay, draw the structures of 2 of these 3 isomers. Okay, and indicate how many different chemical shifts, okay, are there. Okay, now you see they mention same functional group. Okay, don't go and draw ketone. Don't go and change this into aldehyde. Okay, they are telling that maybe you just need to focus on structural isomer. Yeah, so don't go and change, okay, from alcohol over here. Don't go and change something else. Okay, so they just want you, okay, to draw isomer. Yeah, if you have isomer alcohol, okay, 4 carbon, first isomer, 1, 2, 3, 4, no brainer. This is the first thing I will write. Okay, a straight chain, and then I put the OH. Okay, this is isomer number 1. Okay, number of peaks. Okay, how many peaks that you will have? Okay, you see, this is one environment. Okay, this is going to be another environment. Okay, so I have one environment, another environment. Okay, this, okay, is attached to CH3 and then this entire thing. So that's another environment. Okay, if you want me to circle like this, okay, one environment, this one, another one environment. This one is going to be one environment. Okay. If I look at this, okay, this is also going to be a different environment. Yeah. So this one is attached to carbon C2H5. Yeah. Just now is attached to CH5O. Yeah. So it's different. Okay. It's different. So this one and this one, they're different. And this is also going to be different. So how many number of peaks that you have? You count 1, 2, 3, 4, 5. 5 peaks. Okay. And isomer number 2. You have methyl groups everywhere, 3 carbon. So let's actually, they say same functional group. So many others, yeah. I will just, just assume that I'm a little bit lazy. I just put like this, okay. 4 carbon, I bring the OH here. This is also another one. So what you need, you just need to find out, okay, how many different, okay, hydrogen environments. So 1, okay. So this one. So this is going to be another environment. This is going to be another environment. Okay, CH2. So this is going to be another environment. And then CH3, okay, let's see about this and this, yeah. So the hydrogen attached to 2 hydrogen, this carbon, yeah. Hydrogen attached to carbon that has 2 hydrogen, okay, and then CH2, CHOH, CHOH, and then CH3. So if I look at this hydrogen is attached to carbon that has 2 hydrogen, CHOH, CH2, and CH3. Okay, this one, CH, this one is going to be CH2, 2 hydrogen, same. Then after that, CH2, CHOH, CH3. This one is attached to CHOH, which is going to be the same, okay? CH2, not the same, yeah? Okay, this one is going to be attached to CH2, okay, this one is going to be attached to CHOH, so they are different. Okay, I hope you can see, yeah? Be very careful with this, yeah? So you are going to have total 1, 2, 3, 4, 5. Okay, so they might be different isomer also, so that's why they would have given different examples also. Okay, the one that I selected, okay, is going to be, I don't know, just they say structure of any 2 isomer, yeah. So and then they allow the different, yeah. So whatever, yeah, you know what you need to do. Okay, you just need to make sure that you have the correct number of peaks and so on. So that one is done. Okay, if you look at the last question, okay, which is going to be about, okay, carbon 13 NMR. Okay, so for the carbon 13 NMR, so you see the compound F, okay, they mentioned that is a carboxylic acid. And then, okay, the compound F, okay, it means it is carboxylic acid, means this is going to be the structure. And then compound F contains 31.4% oxygen by mass. Okay, molecular ion is going to be 102. Okay, so use this information to show the molecular formula is this. Okay, so if I look at oxygen 31.4, okay, and then hydrogen carbon, we don't know yet. So use this information, molecular ion, okay, RCOOH, okay. Now, RCOOH, okay. To show the molecular formula is C5H10O2. Show all your working. Okay, so, okay, what I can do now, okay, maybe, yeah, I'll try first, yeah. So I'll just put, okay, I do not know what is my R, yeah. And then, okay, I put the C is going to be 12. Okay, oxygen is 16, so 32. Then plus 1. Okay, then total is 102. Okay, let me find out what is R first. Yeah. So that is going to be 44, 45. R is 45, 102 minus 45. So 57. Okay, R is 57. Now, the R can be hydrogen, which is 1. R can be CH3, which is 15. Okay, then R can be C2H5, which is going to be 24 plus 5, which is going to be 29. I'm looking for 45. C3H7. Okay, 3 times 12. Okay, is going to be 36 plus 7. Okay, which is going to be 36 plus 7 for 43. 43. Okay, so let's try C4H. C4, how many? 3 plus 6, 9. So 48 plus 9. Okay, I get 57. So this one. Okay, maybe there are better methods. Okay, but for me, yeah, this one works for me. So it's a C4H9. So I know that the R, okay, so I know it's C4H9, COOH. So you just need to show that the molecular formula is C5 H10 and then O2. See. Okay, this is what I use. Okay, maybe you might have different method. Okay, maybe you want to use this percentage. For me, I didn't use this percentage. What is the reason? Because I know that carboxylic acid, okay, must have COOH. So no point for me to use the percentage. Okay, but there might be other ways. Okay, but again, 1 mark anyway should be fine. Okay, so here, okay, according to the marking key, okay, I think they did almost the same thing, yeah, with me. Now, the next part, there are 4 possible structural isomers of C5H10O2 that are carboxylic acid. Yeah, first one has been drawn for you. Yeah, so here, okay, of course, okay, if it is going to be skeletal formula, very difficult to see. Yeah, so I will suggest, okay, use your display formula. Yeah, for this. So carbon, okay, another carbon, okay, another carbon. Okay, another carbon, then another carbon here, double bond O, OH. This is going to be one of it. So using this, I think enough already. Yeah, so you can actually come up with a lot of isomer. Yeah, the first isomer, I think I'll go for straight chain. Okay, because that's my first thing that I will draw. Okay, this is going to be like this. Okay, later I'll change it into skeletal formula. Okay. Then if you have C over here, of course I can put the C here. Yeah, so another one, C, double bond O, OH. I put the C here. That's going to be another one. Or I can put the CO here. So it means that C, double bond O, OH. Okay, I bring this C exists over there. I bring this C and put it there. So I think I have enough already. Yeah. So drawing skeletal formula. Okay. So 1, 2, 3, 4, 5. Okay. So 5. 1, 2, 3, 4, 5. Okay. And then OH, O, and then OH. Here, 1, 2, 3, 4. 1, 2, 3, 4. Double bond O, OH. Carbon number 2, another C. Okay, that. Here, 1, 2, 3. 1, 2, 3. And then C double bond O, C double bond O, OH. At carbon number 2, there's C and another C. Okay, if I have C here, and there is another C. So instead of drawing like this one looks horrible. Yeah, they tend to draw this, okay, in this form. Okay, this carbon has 3 branches. So rather than doing like that, okay, it's better to draw this way. Okay, so up to you, okay, how you want to draw. Okay, but you will see the answer also is around, should be the same. Okay, thank you. Okay, can you see? So all this, okay, you can refer. Yeah, so they just looking at the aesthetics of it. Yeah, it looks like that. Okay, state the systematic name of isomer 1, the name of this. Yeah, so you see this one is going to be 4 carbons, so it's butanoic acid, Okay, do remember automatically if it is going to be carboxylic acid, this is going to be automatically carbon number 1. Okay, so this is going to be carbon number 2. The methyl group is at position number 2. So it's 2-methyl butanoic acid. Okay, that is done. Okay, let's move on. So F is one of the 4 structural isomers, okay, in B1. a carbon-13 NMR. Remember, I told you this one is very not so popular. Yeah, not so popular, carbon-13. Okay, but they ask also, I told you, not many things to ask. 1 mark only. Okay, only 1 mark. Okay, and then I think this one also related to carbon-13, so it's another 2 marks. Okay, so total 3 marks. Okay, about carbon-13. They cannot ask you too many. Yeah. So here, okay, they have, okay, what I see over here, I have 3 environment for the carbon. Okay, 3 environment for carbon. So what you need to do, okay, you need to go and find out what is isomer F. Okay, they say one of the isomer here is isomer F. So go and find out which one from here has 3 carbon environment. Okay, that is the only thing that you need to do. Okay, 3 carbon environment. So if I look over here, this is going to be attached to CH3. This is 1 carbon environment. Okay, this one, okay, is going to be attached to 2 H2. Okay, so this is, I can see another environment. This one is going to be attached to hydrogen here and CH3. This is already going to be a different environment also. Okay, this is different environment. Okay, that carbon, okay, is going to be attached to carbon with all this. So which is going to be another environment also. Okay, and this carbon is attached to C11OOH. That's another environment. So definitely this is not what we are looking for. Okay, because this is going to be having 5 environment or 5 peak. Okay, you're going to have 5 peak. Okay, so rather than going through one by one, okay, I have some feeling that it might be here. Okay, I have some feeling that it might be that. Why? Because they said if you follow everything, they have a lot. Okay, but here I have 3 only. Yeah, so let's actually try. No harm in doing that. Yeah, if I cannot find, then I still have to do for this. Yeah, so I feel that maybe, okay, it can be this. Yeah, so I know this is one environment. Yeah, and then, okay, if I look at this, okay, this carbon, okay, is attached, okay, to 3 hydrogen and the entire molecule, which is similar to this carbon attached to 3 hydrogen and the entire molecule, which is this carbon is attached to 3 hydrogen and the entire molecule. Yeah, that is going to be one environment. And there is another one more environment, which is going to be this carbon is another environment. Okay, so let me use another. This is another environment. So I know that this is 3 environment already. Okay, so this is, I know that this must be the answer here. Okay, so compound F must be something, a compound, the skeletal formula that has 3 fingers over there. Okay, that shows 3 fingers. Okay, let's see whether the answer is correct or not. See? The compound that shows 3 fingers. Okay, done. Okay, once you know that, okay, the next part, use the data booklet and your knowledge on carbon-13 NMR, okay, to identify the environment and hybridization of the carbon atoms responsible for each of the 3 absorption. Okay, so let's look at the absorption. The height of the absorption, okay, they are not going to tell us anything. Okay, so everything, okay, the height, there is no splitting. Okay, carbon-13, there won't have any splitting. So everything are going to be based on, okay, the value, the chemical shift value. Okay, so we know, okay, they give you the value 27, 41, and 179. Okay, but okay, the carbon environment that I have, you see, the one that attached to C double bond O, okay, and then attached to O, okay, or H, okay. So let's actually find out, okay, what kind of environment is that, okay. Then they say the hybridization, okay. So if I look at hybridization also, yeah, if I look at the CH3, okay, CH3, that is sp3 hybridized. Okay, if you know that, then it's going to be much more easier. Yeah, so you can just look at sp3 only. Yeah, the ch3. Okay, and then you have the entire molecule. Okay, they are sp3. Okay, and then this one also. Okay, they are 4. That is also sp3. Okay, so the carbon is attached to another carbon that has C double bond H. Okay, so this one, I'm looking for this one, and I'm looking for this. Okay, let's see. Okay, let me just bring this. Okay, I put the data here. Okay, Clienta, is it all okay? I hope everything's okay, yeah? Ella, okay?
Yes, sir.
All right. Now, so I'm going to look at, okay, let's look at sp3. Yeah, sp3 may be the one that has ch3. Okay, the value, yeah, the value just in case is 27, 41, 179. 27, 49, 170, 27, 40, 171, 79, 41. Okay, so let's look at it. Okay, I know there is carboxyl group. Okay, so this is going to be the carbon attached to that. Okay, that's going to be 160 to 185. Okay, so this one, RCO2H. Okay, we are not guessing anything. Yeah, so you will get, yeah, you will get the value. And then there is CH3. Yeah, so let's actually look at the sp3, the CH3. Okay, this CH3. So that is going to be around 27. Okay, but do remember the CH3 is next to carbon CH3. Okay, like this, CH3, CH3, and then you have like this, if I'm not mistaken. Okay, so the carbon, okay, definitely not this. No, 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 no. Carbonyl group. Okay, let's look at carbonyl group. This one, yeah. So carbonyl group CHO. This is like this. Okay, the value doesn't match, so no. CO2 already. Okay, then 27. I think the only one that is 27, most likely this one. Okay, or 41. Okay, 41 is attached to the carbon that is attached to CO. Okay, let's see. sp2 next to carbonyl, this one, yeah. 25 to 50. Okay, so this is sp2. So I do have 2 over here. Okay, 0 to 50 is alkyl group. Okay, 0 to 50. And then next to carbonyl group is 25 to 50. Okay, there is no other option. Yeah. So I think, yeah, I think which one I want to select, I think both also can, yeah. 47, 41 is within this range, 27 is also within this range and within this range. Okay, so let's see the marking given. But if I do select, yeah, if I want to select 27 is a smaller number, I will select this one as CH3, and I will select this one as C attached to three things, and then CO2 R. Okay. I'll just bring it back again. Copy. Paste. This one, the environment, okay, I will choose as CH3. This one, the environment is going to be, I'll choose CH3, CO2R, and then the environment is R, RCO2H. Okay, this carbon environment, this carbon environment, this carbon environment. Hybridization, sp3, you can refer to the table. Okay, so sp3. So this one RCO2H. Okay, it's going to be sp2. Okay, let's look at the answer. Alkyl, okay, sp3. Okay, so they mentioned alkyl or they mentioned that CH3. So ours is okay, fine, CH3, fine, sp3. Then they mentioned also, I think it's more clearer if you say next to carboxyl group or this one, CH3, 3, and C. Okay, so they mentioned this. Okay, so I think I put 3 here, CH3, you need to mention CH3, yeah, 3 times. And then I did and mention this and then this carbon, so still correct. And then, okay, the last one is the carboxyl group. Okay, so which is going to be the one that I mentioned also, this carbon, sp2. Okay. Okay, Ashley.
Yes, sir.
Yeah, it's taking longer than I expected. Okay, but yes, okay, let's actually get it done. Yeah. Now, so G is another 4 structural isomer in B1. The proton NMR is shown. Yeah. So you see, the moment you see this proton NMR, sometimes I get very excited. Yeah, because I can see splitting pattern. Yeah, I can roughly know the moment I see this. Yeah, this one belongs to OH or NH. Later I can see. Okay, because it gives me more information. Okay. Carbon 13, okay, it gives me less information. It takes longer time. Yeah, so that is what we have. Yeah, but here sometimes they don't give you the number of hydrogen involved. Okay, that makes difficult. Yeah, but here, okay, they are giving you the splitting pattern. Okay, splitting pattern. Okay, you see here how many? 1, 2, 3, 4, 5. Okay, so 5 splitting pattern. Neighboring will have 4. Okay, 4 hydrogen. Okay, so the actual chemical shift for the 4 absorption, okay, in G and the splitting pattern at 1.6 has been added for you. Yeah, 1.6. Okay, they say multiplet. Yeah, multiplet. No need pentlet or something. No need. Yeah, so 0.9. The splitting pattern. Okay, this is going to be splitting pattern doublet. And then 2.4 doublet also. 11.5 splitting pattern singlet. Number of proton, okay, and type of proton. Number of proton and type of proton. So I think this one, number of proton, definitely 1. Yeah, number of proton is 1. 11.5. The rest, I don't know. Okay, so still need to check. 0.9 from based on our experience on 0.9, yeah, okay, in the past and so on. Okay, that's actually belongs to CH3, yeah. But okay, let's actually check. Okay, no need to assume. Yeah, 0.9, you see, it is most likely CH3, CH2, or CH. Yeah, so CH3. Having for here. Number of proton, this one correct. Okay, number of proton 6. Okay, let's see, 6, 1, 2, 1. 0.9, okay, is 6. G is another of the 4. Okay, sorry, I missed out this. Okay, so they say that G is another of the 4 structural isomer in B1. Yeah, remember just now, okay, we did this. Okay, I thought it's a different question. We did this. Yeah, we already identified this. Okay, so now, okay, what rather than looking at them one by one, yeah, you can just look at, okay, they have 1, 2, 3, 4. Okay, 4 environment. Okay, for the hydrogen. So let's actually look at the hydrogen that has 4 environment. Okay, so the one that has 4 environment. Okay, let's look. 1 environment. This is going to be another 1 environment. This is going to be another new environment. Okay, this one is going to be another new environment. This one, another new environment. Okay, I don't think so. This will be the answer here. 1, 2, 3, 4, 5. 5, we want 4. Okay, this one no need to do. Actually, this one, they just give us carbon environment, but they say another one, yeah. So it's okay, we try this one. CH3, so 1 environment. Okay, and then this is going to be another environment. Okay, and this is going to be 1 more environment. Another 1 more environment. And then CH3 bonded to carbon. Okay, this is going to be another environment also. So how many? 1, 2, 3, 4, 5. So 5. Okay, let's try with this. Okay, most likely this one. Okay, let's see. CH3, CH3. Okay, this one attached to H. Okay, I know that this environment, okay, is the same as this environment. Okay, you can see they're the same. This is going to be a different environment. Okay, and this is going to be different environment. And this is going to be a different environment. So how many? 1, 2, 3, 4. This is the structure that we are looking for. Okay, I hope you can understand, yeah. So maybe it's difficult, okay, but just go through this again, yeah. So this is the structure we are looking for. So this will actually make our life easier, okay, when we are looking at the number of proton and so on. So I think if you cannot see, so we can always draw this again. Okay, hold on. Bring this. Okay, if some people, like for me, it's very hard for me to see from the skeletal formula. Yeah, I will prefer displayed formula. Okay, so for now, okay, I know that the one that is singlet, okay, the type of proton is going to be the OH. Okay, so this one no need to worry so much. So this one definitely the one that is attached to oxygen. Okay, that's the proton. And if you look at the others, okay, you see the one that gives you multiplet, okay, the one multiplet, okay, it means that, okay, the adjacent to the carbon, okay, which is going to be, I think, this hydrogen, okay, adjacent to it has 6, okay, so that's why the number of proton is going to be 6, okay, this one. So let's say 6, then only they have multiplet. So it means this one is the one that will give you the multiplet. Okay, so the hydrogen is attached to C that is attached to 3 R groups. 2 R groups, and then C double bond OOH. Okay, so that is going to be number of proton. There's only one. Okay, so if this one is that, okay, so the another one, okay, the 0.9 must be the CH3 group. Okay, we already know. Okay, that is CH3 group. How many CH3 group that you have? They are going to be hydrogen. There are 6 hydrogen, 6. And then the 2.4, okay, no need to worry. This only this, so 2 hydrogen. So 2 hydrogen. Type of proton, okay, the proton is the one that is attached to carbon that has, okay, I think you can see this one, the carbon that is attached to R group. Then they are attached to COOH. Okay, so how do they represent that? Okay, in the marking key. Okay, let's see. Definitely this one, no problem. Okay, let's look at the type of proton. How do they represent the marking key? Okay, they represent by just putting CH3 is okay. Okay, type of proton, alkane. Okay, they just use the term alkane. And then 1.6, they still use the term alkane. They do not give you in detail like what I did. This carbon attached to this, there. Okay, they just use the term alkane. So it means this is also going to be alkane. Okay, CH. Okay, so the type of proton is going to be alkane. Alkane. Okay, but still, I think it's better to also mention more detail. Yeah. So 2.4, okay, is going to be what kind of a structure? The alkyl next to C double bond O. Okay, that is the how they explain. Okay, alkyl next to C double bond O. But I mentioned this one, everything. Yeah. So I think better to try to follow this. Yeah. So 11.5 OH. Okay, so you see OH and then or they say carboxylic acid. So up to you. Yeah, for me, OH is fine. Okay, this one is done. Okay, now I know it's already 8:32. Okay, let us finish. Yeah, so only last one. Okay, now the last one, okay, is going to be deduce which isomer is G and draw the structure in the box. Yeah, I think just now we already draw. Okay, just bring this one. Okay, put it here. Okay, done. Okay, and then okay, give or name and give the formula of suitable solvent of obtaining a proton NMR spectrum. Proton NMR. Okay, solvent. Yeah. Okay, let's see whether you guys remember this. Ashley, what is the solvent?
Wait, sir, is this low? This is high resolution, right?
Okay, don't worry about high resolution and so on. Yeah, do remember, okay, TMS, okay, is a reference compound. Okay, TMS is a reference compound. If they are asking about solvent, okay, solvent is going to be, okay, this one. Okay, this is going to be, you can see, CdCl3. Okay, or they say you can use CCl4, all that. Okay, but the moment that they ask solvent, okay, let it be proton NMR, let it be carbon NMR, carbon-13 NMR, it's always going to be CdCl3. If they ask you name and give the formula of a suitable reference compound, yeah, reference compound is, okay, is going to be tetramethylsilane, yeah, so Si, tetramethylsilane, SiCH3, CH3, CH3, and CH3. That's reference compound. Yeah. So please remember this. Okay, CdCl3. And I told you, okay, if they want to ask another one more mark, okay, why we don't use, okay, if I continue this question to make it 14 marks, why we didn't use, okay, CaCl3? Yeah. So then you should be able to answer. Yeah, Ashley.
Can I answer that, sir?
Yeah. You want to answer? Yeah.
Yeah. B is like H2, and then we have to use an even number so that it will only appear as a small peak at 80 ppm. If you use like the other hydrogen variants like H1 or H3, they will give a disturbance energy.
Yes, correct. Yeah. So even you see when we explain about that, you can at least look for 2 points or 1 point. So they can still extend this question to another one more mark. Yeah. So you just take note. So all this is done. Yeah. So it's completed. Okay. So next week we can start fresh with paper revision. Yeah. So that's it for